Good day. So we're now in our final video for the basics on angles on geometric figures. Let's look into angles on quadrilaterals. Well, we won't take too long in discussing squares and rectangles. We all know that each angle in a square or rectangle is equal to 90 degrees. But it will also be interesting to look into figures like what we see here on the screen, which is a parallelogram. Parallelogram has two opposite sides that are parallel to each other, and the other two are also parallel to each other, hence the arrows that you see here. This one, that means they're parallel to each other, and this is parallel to this one. And what's interesting is, if it's a parallelogram, we know that the opposite angles are equal to each other. Okay? So this 120 degrees here is actually of equal measure to the other one here. And at this point, looking at the figure that we have, it's clear to see that this is also 120 degrees. And if you remember, the sum of all the angles in any quadrilateral is 360 degrees. And being aware of this, you can actually solve for the other two angles here. All you have to do is subtract 120 degrees and another 120 degrees. And you'll end up with 120 degrees. But remember that your 120 degrees is the sum of this angle here and this angle here, and they're equal. So you have to divide that by 2. So each angle over there that's marked red is 60 degrees. And that's how we actually use the properties of quadrilaterals and use it to solve the various angles within these quadrilaterals. In fact, if you use these properties, you can eventually actually solve for angle V over here, this one. But that's for another time. So let's focus now on angles and parallel lines. We've figured out the different angle measures within this parallelogram. And if you notice, AD over here is parallel with BC over here. And it's intersected by this other line, AB, over there. And if you remember your lessons on angles along a straight line, if we extend this here, and this one over here, we can see that the angles formed on the other side of each angle inside this parallelogram, beside 60 degrees, is 120 degrees. While at the bottom of the parallelogram, the angle beside 120 degrees, if you extend this line, is 60 degrees. So 120 plus 60 is actually 180. And can you see the angles that have the same measurement? You're right. The two parallel lines, the colored green, if they are intersected by a straight line at any point here, creates angles that are equal if they are in alternate positions. These are called alternate interior angles. And they are equal, given that you have two parallel lines and it's crossed by a line that intersects the two parallel lines. This one is actually, any line that does this is called a transversal. It's that one over here. That's a transversal. This one too is a transversal. Let's highlight that one too. This one is a transversal as well, just so you know. So that's applicable for any example. And one more thing that you may have noticed, if you look closely, these two angles here add up to 180 degrees. Right? So if they're on the same side of the transversal, they are called interior angles. So if interior angles inside two parallel lines crossed by a transversal, they add up to 180. But if it's alternate and they're inside, they're of equal measure. And those are the different patterns and properties that we can see in angles when you have parallel lines. And that ends our video on the basics of angles in geometric figures. In the next series of videos, we're going to be tackling examples and how to apply these properties. And hopefully you get the hang of it. Good day, and see you in the next video.